This lecture is a combination of the sections on simple interest and compound interest. So I'm going to scroll down here for simple interest, and I'm looking, trying to look at these two blue boxes here. I'll scroll a little bit down to the next page. There it is. So simple interest is really simply calculated. It's right here, that formula. So as an example, take you're investing $1,000 at a rate of 5%. So you multiply by 0.05, and you can figure out 5% of $1,000 is $50. So you get $50 in the first year. And the second year, you get again $50. And then the third year, you get again $50. In the fourth year, you get again $50. And so you keep adding the $50 to it, which means that basically the total interest that you earn is 1,000 times 0.05 interest rate, or 0.05, times 4 years, and well, 4 times 50 is 200, so you have an extra $200. There it is. And that's what you add to the principal, so you have 1,000 plus 200, and obviously that is going to be $1,200 with an investment of 1,000. The second to last one, where it says here 1,000 times 0.05 times 4, that's this calculation here. Interest equals the principal times the rate, the 0.05%, times the time, 4 years, for example. Of course, you can also do that in the spreadsheet. Here it is. So again, here's my $1,000. Here is the, let's see if yeah, that's fine, that's good enough. Here is the interest rate of 5% and term length of 4 years, and we can see, well, after 4 years, there's the $1,200, right, and added $50. So simple interest is really straightforward. A couple more examples here. So 4,000 here with the 5.5%. So again, once I find my calculator here, somewhere, there it is. So I'm going to clear this out here. So 4,000 times 0.055% now, times 4 years. There we go. $880 extra, so a total of 4,880. And again, if I put that here, what was it again? 4,000, right? 5.5%. There we go. And there is that after 4 years, $4,880. By the way, in my little spreadsheet here, I cannot use the 5.5% for the calculation. I have to use the decimal, which is 0.05. So I can either divide that by 100 in any formula that I use. Notice here in the formula I actually don't do that. However, see this little purple part here, if that's the color, which highlights this field here. So this is actually where in like really faint gray I put the decimal, and that one actually is divide by 100, the percentage rate. So that's how I get the percentage into the decimal. Okay, the other example here. So 14,800 times 0.079, so 7.9% times 7 years, and hit the enter, and so an extra $8,184.40 plus the original principal, so $22,984.40. And again, on my Google sheet here, let's see, I have to figure out 14,800. I might have told you before that I have a very bad short-term memory, so 7.90 here, and that was at 7 years. I think so. Geez, something else keeps popping up here. 7 years. By the way, this particular field doesn't really do anything. There is the $22,984.40, and each time we have the annual one here being added. Apparently, you notice the difference here, top of my head, 1,169.20 is added every single year, simple interest. All right, I had to look up actually what the simple interest is being used for. Usually compound interest is the more interesting one. We're going to get there very soon. So here I looked that up. When simple interest is used, okay, car loans are more than not amortized monthly. Retail installment loans also calculate monthly. Short-term financial transactions with a time frame of less than 1 year. So that's where simple interest is being used, otherwise compound interest. Again, I made a disclaimer there. Do not take any financial advice from me. I know the math, and I'm trying to apply it here and teach this one here for this chapter here. But again, I'm not a financial expert at all, so do not take any financial advice from me. All right, so in this particular section here on simple interest, that's actually what I want to talk about. Notice I did put a few more frames here, and I will actually return to these here in a little while, but I want to cover compound interest next. So there we go, and so I'm going to give myself a break, and this is where I'm going to start out next. All right, so here's compound interest, and compound interest means not only do you earn interest on the principal, but you also earn interest on the interest from the previous period that you got the interest from. And compound interest is good for investing money. You get more and more interest, compounded interest. But of course, when you take out a loan, and usually loans, longer loans, definitely based on compound interest, yeah, you would have to pay off more. So, and of course, banks and our investments go with compound interest, so it's kind of more important than simple interest. Again, whatever I say about finances, take it with a salt of grain, because I'm not a financial expert. All right, so here is an example. Interest compounded annually. Ambina invests $1,000 in a CD, certificate of deposit, earning 4% compounded annually. How much will Ambina's CD be worth after 3 years? So if it was simple interest, she would earn 4% of $1,000, $40 every year, and it's 3 years, so 40, 40, 40, $120, and she would come out with $1,120, but it's compounded annually. So let's calculate. What I'm going to start out with is actually the formula that was used earlier for the simple interest. So 1,000 times 0.04 times actually just the first year. There we go. And we should get $40, right? Now, what's going to happen is that is being added to the 1,000, and I don't have to put that on the calculator. I just added, right, $40 to it. And now I'm going to do times 0.04 for the second year, and notice that what I just did a moment ago is step 1 here, and what I'm doing now is step 2, again times 1 year. This would be actually a second year. Notice that the new principal is $1,040 now. So I enter that, there we go. And now I have this new number, which then is going to be $41.60. So it's not $40 more, it's $41.60. So a little bit more. And so I'm going to add this one here. I'm also going to do it in my head. And then for the third year, again, 0.04%, as if it was simple interest, but of course it's compounded because the principal is new every time. And I'm going to come up with an extra 43,264, which, okay, this time around I'm going to do it with the help of the calculator. Let's see, there we go, and there we go. So $1,124.86, which is exactly what it says here. Compared to simple interest, it would have been $1,120, so a little bit more, $4.86. For short terms, which is what I'm saying here, for short term times, compound interest is only a little larger than simple interest, but for long times, it can be appreciably larger. And down here in this box, they say, okay, we'll revisit this one here. And yeah, 1,120 with the simple interest. and then $1,124.86 with the compound interest, actually using the simple interest one after for each year, but with a new principal. So there ought to be a simpler formula, and this is what it is right here. In fact, this one is the simplest formula of that, so I'm going to apply that to the calculator. I have to find my calculator again. There it is. So what I'm going to do here now is I'm going to take the original principal, $1,000, times parentheses 1 plus the rate. Well, that's the 0.04. I close the parentheses, and now to the power, if it was 1 year, I would just multiply times that once, I would come up with $1,040. Now, if I do it for 2 years, then that would mean here with the exponent 2 means I multiply with this parenthesis twice. So the second time I multiply, I have a new principal, the $1,040. So I will come up with the $1,081.60. Let's just do it. There it is, right? But of course, it says that the loan is actually 3 years. I'm sorry, not the loan, but the investment. Was it a loan or was it an investment? I forgot. So here now I multiply with this parentheses, which is actually 1.04 3 times. So that is the compounding part. I multiply with that parentheses, which has the interest in it, over and over again, and that gives me the compound. And of course, when I do that, I come up with that $1,124.86. Let me just see if this was actually an investment. Yeah, it was an investment, certificate of deposit. Now here, that would be my simple versus compound interest. So this was $1,000 CD, 3 years. Again, actually in my little sheet here, it doesn't really matter what I put in for years. And what was that again? Oh, 4%, right? So 4.00%, and there it is. And here are the two numbers after 3 years. That's the same numbers that I just calculated and that you saw in the text. This one here, 3 years, by the way, is here approximately. So it starts as $1,120. Notice that for a very short time, 3 years in this case, there isn't much difference, $4.86, right? But the more it is, simple interest goes up linear, so you keep adding $40 each time. But compound interest, because you're earning interest on the interest, goes up like this here, and you might actually recognize that as a kind of exponential curve. So given more time, not just the 30 years that I have, this one here goes up quite high, almost skyrocket. But of course, we have limited time spans. So if we invest this here for 1,000 years, yeah, it would be worth a lot of money, right? But that would be a number of generations down the line, future investments for our descendants. All right, so that's an intro to compound interest. I'm going to give myself a little break, and then I'm going to continue. Now here, I noticed that, of course, there is a calculator out there. You don't have to rely on my spreadsheet here. So again, it's calculator.net. Actually, it's the first time that I use calculator.net. So here I have initial investment of $1,000. Interest rate, it's at 4%. And I have an investment length of 3 years. And I'll leave the other stuff here. I don't need any of the others. Here, so calculate. And there we go. There's the $1,124.86 here. And then it splits it up into, well, that's the initial investment, and then this is the interest here. And that, of course, is compounded one. On calculators.net, I couldn't find a simple interest calculator. So this is the compound interest calculator. There, oops. Which one did I use? Interest calculator. I couldn't find a simple one. Maybe because it's too simple. They don't need it. This one actually does have an interesting thing in here. As money grows, when you invest it like this, you get a certain interest rate. Well, you have to pay attention to inflation. What it says it's right here. If I put 0% here, by the way, there we go. What happened is actually one of the numbers went away. So you truly actually have $124.86 more after 3 years. But what if the inflation is around 2%, which in the United States it quite often is around 2%. So let's see what happens here. And so here what it says is, well, you still have the $124.86 more for a total of this, but the buying power of the end balance after inflation adjustment is this much. So it's not $1,124.86 in today's dollars, but it's being actually less than that. So you actually only gain about $60. What? Because there is inflation. Things are getting more expensive. What if the inflation rate actually is the same as the interest rate? Well, there we go. Buying power is $1,000, just like it is today. And if the inflation rate is larger than the interest rate, or the interest rate is smaller than the inflation rate, either way, it's the same. So for example, if this is only 2%, well then, watch what happens. The buying power is actually less than what it is today. So sometimes you can say that does actually make sense to invest money at an interest rate that is lower than the inflation rate, or do something else with the money. And again, I'm not a financial advisor. All right, wanted to show this one here. So let me get this one here back to 0%, and our original one there, let's see, 4% interest rate. There we go. This is the original number that we had. All right. This particular formula, this is what I just used here. So you just keep multiplying with that, and I showed on the calculator, this is what you would do. And so, for example, one of the numbers I had, let's say if it's 10 years, where did I put that? For this one here. So if it was, for example, 10 years right here, you would expect $1,480.24. So if I do the same formula here with to the 10th power, so I keep multiplying with this parentheses of 1.04 10 times, and indeed there is the $1,480.24 after 10 years. Yeah, there's a slightly more complicated formula. You see that in here? It appears twice. You divide the rate, so the 4%, by that n, and what it says here is it's compounded n times per year. For example, per month, so n would be 12. But then you also have to put it in the in the exponent here, so you would have to put a 12 here, and when you do that, it would look like this. So I'm going to just clear this one here, and there is to the 10th power, right? And here I'm going to do it again, but this time around I divide the interest rate by 12, so by 12 months. There we go. And then, as it said right here, the exponent is actually 12 times, so the 12 appears twice, and the denominator for the interest rate, and then there's a times, there we go, as I'm talking, and then in the exponent as well, and what you come up with is a slightly larger number, in this case $10 more. So if it's compounded more often, like 12 times a year, you get a little bit more out of it. We will use that kind of compound interest formula when it comes to looking at loan payments, because those payments where you pay off a loan are usually per month, so we would have to use that 12 in there. One last thing I want to do with this one here is to show that if you compound it even more often than the 12 months or 1 year, for example, daily, 365, you come up with an interesting number. And so what I'm going to do is I'm going to have an investment of, let's say, $1 times 1 plus, and let's make it 5%, 0.05. And then I'm going to make it for 20 years. By the way, 0.05 times 20, which is not, it's not in this formula, I'm just saying 0.05 times 20 is 1, that's actually on purpose. So $2.65, after 20 years, the $1 grew into $2.65. So what happens when you do it every month. So you go in here, divide by 12, for 12 months, and then you go in here and 12 times the 20 there. There we go. Put that one back there. There we go. Okay. $2.71. Again, a little bit larger, right? And I'm going to do this again. Instead of 12 months, I'm going to do it weekly. So 52 weeks in a year. Look in the calendar, 52 weeks. There we go. And again, a little bit larger, 2.716. And as a mathematician, that reminds me of something. And I'm going to share that here on my spreadsheet. So continuous is what my tab is called. There's the 5%, there's the 20 years. We just saw this one here annually, so it's only a 1 in there, which means that the n really doesn't appear in the formula. And it's 265. I showed the monthly, $2.71. I showed the weekly, still a little bit more. Actually, let me check. Was that true? Yeah, just a little bit more, right? $2.71 and another 69 and so on. And then daily, this is where it would be 365, and then hourly, whoa, $2.71, 82, and so on. And when it's continuous, so that it compounds itself like every second, and even faster than that, you come up with this number, 2.718, and so on. And as a mathematician, we're reminded that is exactly the number e, which we know from the exponentials. And when you look up the number e, the mathematical constant, here it is, the 2.71828. And one of the first things it says is, well, this is actually the compound formula. And it's, even though it's called Euler's number or Napier's constant, it was actually discovered by Jacob Bernoulli, who was a Swiss national, actually just like Euler was. And let's see where it says that. Oh, right there. The constant was discovered by the Swiss mathematician Jacob Bernoulli while studying compound interest. And yeah, here's the interesting thing. This is what's called Euler's identity now. This particular one here where we have that E in there, and I have a cup that I might show here in this little video. I have to figure out how to turn my video on. So that E that we have here, which is a very important mathematical constant, just as important as pi is right there, was actually discovered by doing compound interest. And back in the 17th century, when he discovered that, it says here, discovered 1685, I'm sure it was, he didn't have the luxury of having a spreadsheet. He had to do it by hand. He didn't have a calculator. He might have had an abacus, but I'm sure it was relatively tough to calculate. All right, as I said, I'm going to try to show my cup here in a moment, and then I have a little bit more. All right, so here's my coffee cup with all kinds of formulas, and there it should show up, I hope. It's such an important formula, the exponential there, the e to the I pi plus 1 equals 0, that they even put it on coffee cups. But in any case, number e is very important in mathematics. That's what gives us the exponential function that we have used prior in a number of examples. And it comes from determining compound interest continuously. All right, I want to talk about a little bit more here. Earlier on, I talked about simple interest, and I did these examples here in the simple interest formula here. And scroll a little bit up. This was my opener. And you might have noticed that I skipped actually my little comment here, which is simple or compound. And I'm saying I'm not so sure. So APY stands for annual percentage yield. It says 2.00% here on this 5-year CD. So if I invest $1,000 here, that would mean I get $20 every year. And if it's simple interest, then it's $20 5 times, so which is a total of $100. So I should come up with $1,100. Well, I did find, of course, a CD calculator somewhere here. And I'm going to put $1,000 in there. Okay, that's actually already there. And then I'm going to put here, it's at 5 years, right? So 5, getting there. There we go, 5 years. And 2%, it says right there, APY. And it's not $1,100, it's $1,104.08. So this is actually compounded. You know, when I put that in the calculator, we can easily see that. Of course, if it was $1,000 simple interest, so times 0.02 times 5 years, I would get an extra $100. Add to the 1,000, I got 1,100. But if it's compounded, I get 1 plus 0.02 to the 5th power, so it's compounded every year, and there is the $1,104.08. So that's why I'm saying I'm not so sure if that APY is simple. And there's another example here. Her name is Mia, so I have to find her. I think it's a your turn. And there's Heather, and let's see, is she showing up? There she is. Mia deposits 4,900. So if I did that straight on my calculator, let's see, then 7 years, 3.95, so 1,000, no, not 1,000, $4,900 times 0.0395 times 7 years, so an extra 1,354.85. So I add that to the 4,900, so I should get 6,254.85. And I looked at the solution manual, which is this one here, so 6,254.85. And let's see, where is she? There we go, 6,254.85. And there's that's exactly right here what I did in the calculator. So this one says it's simple, but again, if I go to this one here, the CD calculator, in this case, where it also says APY, oh, there's always these pop-ups here. So I put 4,900 there, and it's at 7 years. There we go. 3.95, there we go, which is more, actually, almost $200 more, right? $170 more than the simple interest. So again, I'm not so quite sure what they're seeing here. So maybe definitely be cautious about my financial advice. I keep repeating myself, do not take financial advice from me. I know the math, but I don't know the finances. And apparently the book is saying, oh, this is simple, but I think it's compound in this chapter here, in this section. And if I go down here, there was another one where I mentioned that right here, where it says repeated partial payments, car loans, and mortgages, which is what I'm going to do in a future one. And you will see this particular formula here, which is still amazing to me. It looks like a complicated formula, but I will claim in a future video that as a mathematician, that's actually a relatively simple one. And notice when you look at this formula, that's actually the compound part in there. And again, I'm saying, hey, I'm not so sure. This, by the way, is the loan payment formula. All right, I think I got it for these two sections actually on simple and compound interest.